Welcome to some trigonometry here. We're going to be looking at the 6 trigonometric functions. A lot of you are very familiar with your sine, cosine, and tangent, but we're also going to throw in some cosecant, secant, and cotangent. Now, if you look right here, I know you love your SOHCAHTOA, which is fantastic, but we need to realize that there are 3 more trig functions out there, and they are the reciprocals of the ones that we really like. So if you think about all of these angles being in a right triangle, the acute angles, of course, not the 90-degree angle, we have our sine being opposite over hypotenuse. Great. So that means the cosecant is how you say that, the CSC, right? The cosecant is the hypotenuse over opposite. So you can see which ones are related here. Now, I get a question a lot of like, well, how do you remember which one goes with which? Well, right here, folks, the cotangent has to go with tangent just because they both have a T. That does not mathematically sound at all, except they are the same word, right? Tangent and cotangent. Now, the other two, I will always tell you, the S goes with the C and the C goes with the S. And so everybody mixes those up and they try to put sine with secant, and that is not correct. So that's the non-mathematical explanation of how I've always remembered which one goes with which. So cosecant's the reciprocal of sine, and secant's the reciprocal of cosine. Another way to look at it is like so. So right here, instead of like looking at it as like opposite of our hypotenuse, it really is just the reciprocal of its counterpart. So if you know the tangent of something, you just look at the reciprocal for the cotangent. And there you go. Let's go ahead now and look at an example. Here I have a lovely right triangle, and it looks to me like I only have a leg and a hypotenuse. And I will say to do all 6 trigonometric functions, I'm going to need that other side. So the first things first, let's go ahead and solve for it. So we know our Pythagorean theorem, a squared plus b squared equals c squared, where c is always the hypotenuse. If I subtract 4 from, oops, that is not a plus sign. Let's change that. There we go. If I subtract 4 from both sides, I get x squared is equal to 5 and the square root of that, and x is equal to radical 5. Now, I'm not in any particular quadrant, and so I'm just treating all of these as being positive values. And if you're confused by that statement, you'll see what I'm doing here in just a minute when we start looking into different quadrants. So right here, x is equal to root 5, so I'm just going to put a little root 5 there. And now we can go through and fill out everything we want to. So if we're looking at the sine of theta, we know that's opposite over hypotenuse. Great, so 2 over 3. So if we do the cosecant, we just flip that. 3 over 2. Great. Let's go ahead and look at the cosine of theta. That's adjacent, right? So if this one's the opposite and this one's the hypotenuse, this one is our adjacent. So radical 5 over 3. And then the secant is going to be 3 over root 5. But that's probably not the best answer because, our teachers don't want us to have a radical in the denominator. Even though it's the same value, it's just not proper. So let's multiply by radical 5 over radical 5, and we get 3 root 5 over 5. And that's just a better answer for it. Okay, the tangent of theta, opposite over adjacent. Ooh, yeah, I'm seeing this radical 5 thing happen again. So let's do radical 5 over radical 5. And again, we'll get 2 root 5 over 5. Great. Now the cotangent, it's easier if you just look at this original one because 2 over root 5, if I go ahead and just do the reciprocal, I get root 5 over 2. Yay! Okay, so there are our 6 trigonometric functions. So remember, in a unit circle, the cosine is related to the x value because, again, we're looking at the unit circle where all the hypotenuse of each triangle is going to be 1, right? That's why it's a unit circle. So cosine is x over 1, whereas sine is y over 1. So we just look at it as being x comma y. So if we think about the signs of these, cosine and sine are both positive in the first quadrant. Cosine is negative here, whereas sine's positive in the second quadrant. Let me label my quadrants. The third quadrant, both are negative. And in the fourth quadrant, we have positive cosine and negative sine. So why is this important? Well, you may get a problem like this. where it says, hey, here's the cosine of the angle, and I want to know all 6 trigonometric functions. I only have the cosine, I want all of them. But guess what? Sine is negative. So if I think about where is cosine positive and sine negative, I'm looking down here in quadrant 4. So when I draw my triangle, that's right, I draw my triangle, I'm always going to be, first of all, I'm just going to draw whatever line here. It doesn't have to be, drawn to scale. But when I do this, I always connect it to my x-axis. A lot of people want to go ahead and connect it here, and that is not okay. Do not do that. Your theta needs to be kind of like treated like a reference angle, so it needs to be close to the x-axis, right? The x-axis needs to always be that adjacent. So right here, if I do look at cosine, I know this must be the adjacent over the hypotenuse. So here is the adjacent over the hypotenuse. And then we can still use Pythagorean theorem, unless you already know your lovely Pythagorean triples, and you know this is one of my favorites. So, but it's 5 squared plus x squared equals 13 squared minus 25 minus 25, x squared equals, so 169 minus that, and there you go. And we get x is equal to 12. Yay! Okay, but guess what? It's technically not equal to 12 because we are in the 4th quadrant. Okay, so that is a negative 12. We are going to treat that as a negative 12. I don't know why I wrote negative 1 over here. I'm fixing that right now. There we go, positive negative. So negative 12 is our, and I should have probably done a better job and called this the y value, since it is the y value here. All right, so we can go through now and answer all of our sine, cosine, all of those questions. So sine, we have opposite over hypotenuse. So it is in fact negative because it's negative y value, right? Because if you think about this point is 5 comma negative 12, and that's where this is coming from. All right, so negative 12 over 13. The cosecant will then just be negative 13 over 12. You can put the negative sign in front. I just prefer the negative to be in the numerator. That's just a preference I have. Your cosine, though, that was given. So automatically, without even the picture, we should know the secant because we just do the reciprocal. And then, of course, our tangent, opposite over adjacent, so negative 12 over 5, and the cotangent being negative 5 over 12. Whoa, Miss White, can we do another one of those? Sure, let's do another one of those. All right, so here we're throwing out a tangent. Ooh, nice, tangent. So the tangent's positive 7/9, and the sine is less than 0, so sine is negative. Wait. What's tangent again? That's not cosine or sine. You're right. When we look at the tangent is going to be opposite over adjacent. And so if you think about what the opposite over adjacent is when you're looking at like a y and an x here, you're looking at y over x. So sine over cosine is going to be your tangent. So let's think about that then. If cosine and sine are both positive here, then sure, tangent is also positive. Yay! But this one tells me sine's negative. Oh, well then let's go over here where cosine and sine are both negative, which means if I have tangent, that's negative divided by negative, which equals a positive. Ooh, okay, so we are in the 3rd quadrant. So I'm going to draw my triangle in the 3rd quadrant. And again, you want to connect that to the x-axis. You want to have your theta right there. Your adjacent should be the x-axis. And here, if you think about this is your opposite over adjacent, so 7 over 9. But there's something wrong with this because we are in the 3rd quadrant, and in the 3rd quadrant, the cosine and sine are both negative. So because of this, technically, the 7 and the 9 are both negative, even though obviously when you divide those, it becomes a positive value. And so that's how we're going to treat those, because that way when we find our sine and cosine, we'll get those correct sine values on those. Let's find the hypotenuse now. We have technically negative 7 squared, but we know that that's going to go ahead and give us a positive value anyway. So 49 plus 81 equals h squared. That's 130 equals h squared, square root, square root. that's 2 and 65, and that's 5 and 13. So nope, that does not simplify. So there we go, radical 130. Okay, now we are ready. Sine of theta is equal to opposite over hypotenuse. Yeah, you guessed it. We can't have a radical. Oops, there we go. Messing up my numbers here. Radical 130 can't have a radical in the denominator, so we're going to go ahead and write it like that now. 7 does not go into 130, so that is as simplified as I can get it. Now cosecant, like I said before, go ahead and make sure you're looking at this one and don't try to take the reciprocal of our final answer, because then you're just going through and rationalizing again. So here is radical 130 over 7 with a negative in front, because those are both negative. If I do the cosine, I'm looking at negative 9 over radical 130. And again, when I rationalize that, negative 9 radical 130 over 130. For the secant, go ahead and just do the reciprocal of the one above. So radical 130 negative, that is, over 9. And we already know the tangent because that was given. That's the easy one. And therefore, cotangent's pretty easy too, because we just do the reciprocal of the tangent. All right, so again, please be careful of what quadrant you are looking into when you're looking at your 6 trigonometric functions. If cosine's negative, then so is secant. If sine is negative, so is cosecant, right? So that's why these are all negative here, because those follow suit, whereas your tangent and cotangent are positive. So be careful of which quadrant. All right. Thank you.